Page 131, and we have three major types of bonds that we need to get memorized. So what I'm going to tell you is that at a very general level, we're just going to look at the element combination, and when we see particular element combinations, we're going to identify it with the type of bond. So one type of bond is a metallic bond, and when we look at a chemical formula, the formula only contains metal atoms. So I'm just going to put M plus M. If we take a look and we see an element combination where there is at least one metal and at least one nonmetal, then we're going to say ionic bonds exist. And if we take a look at a structure where every atom present is a nonmetal, then we're going to say they're linked together with covalent bonds. So get this combinations memorized. Now, the different type of bond, it gives us an idea of what is going on with valence electrons. So here we go. So let's start with the ionic. So our key buzzwords of when a metal bonds with a nonmetal, the reason they bond is because what occurs with those valence electrons, and we are going to put it down to basically three words. So ionic bonds formed when there is a transfer of those valence electrons. So the key word here is if it's being described as being transferred, that's an ionic bond. We need to get that memorized. Covalent, so co, that prefix like co-workers, co-captains. So that if you understand that prefix, it'll help you understand what's going on with valence electrons. So in a covalent bond, the valence electrons are shared. So co, like co-captains, co-workers, they share the responsibilities. So in a covalent, they share the valence electrons. And then metallic. Way over here, we have sounds like a little bit of an outrageous saying, but it makes it easy to remember. So a metallic bonds exist in structures where you have a sea, like an ocean sea, a sea of mobile valence electrons. So metallic is always going to be described as a sea of valence mobile electrons. Ionic is always going to be described as a transfer of valence electrons, and covalent will always be described as sharing valence electrons. And then our element combinations. Get that memorized. Now, you know there's always a little something to watch out for. So if a compound contains a polyatomic ion as its anion or cation, so something from table E shows up in that chemical formula, then the structure contains both ionic and covalent bonds. So the poly, so NH4 is the poly here. What links those non-metal atoms to make that poly, that's the covalent. And then those brackets that we put side by side, where the poly is bonded to the other guy, that would be what represents the ionic. So if a compound contains one of our table E guys, both covalent and ionic are present in the structure. So here we go. Take a look at some examples for bond classification. So I take a look at MgO. Mg is in group 2, so it's a metal. O is way to the right of that stair step. It's a nonmetal. So if it's a metal bonded to a nonmetal, I would say that the bond classification, the best fit, would be an ionic bond. When I take a look at NH3, N is to the right of the stair step, so it's a nonmetal. H is in its own category, and we've noted since the beginning of year it's a nonmetal. So we have a nonmetal bonded to another nonmetal. This would be an example of a covalent bonded structure. Now, Al, I know it's not a compound, but you have to think beyond the idea. So Al stands for aluminum. You guys use aluminum all the time. You don't use an individual atom of aluminum, but you tend to use, you pull out the roll of aluminum foil and you pull it out and you tear off a sheet of aluminum that has trillions and trillions of aluminum atoms. So think about like aluminum foil, which is made up of trillions and trillions and trillions of aluminum atoms. They are bonded to each other. Every single aluminum atom in that sheet of foil are all metals. So the aluminum foil represents a metallically bonded structure. Okay, and we have a couple of we-dos. So now I take a look here and I see this compound that's got more than 2 elements in it. So that's a big clue for me that it's probably a table E. And when I look on table E, I see this poly. And then I also notice, hey, this is also a poly. So I have a poly ion here. I have at least one poly ion. So if there is at least one poly ion, either the cation or the anion or both, that means that I have both ionic and covalent bonds present in this structure. Taking a look at the last we do, carbon is to the right of the stair step, so it's a nonmetal. Hydrogen, it's up in the heavens, and we've memorized and have noted it's also a nonmetal. So in this structure, we would expect only covalent bonds. So carefully look at the you-dos, come up with your bond classification, ionic, covalent, metallic, or it contains both ionic, covalent. Check your answers with your teacher.